Hi, in this video, I'm going to show you how to use breadth-first search to find the path of a maze. Before I do that, just briefly go through what I've done in the last video. In the last video, I've used depth-first search to build a maze. If you enter the dimension of the maze, output will be an array, and I create a function to draw the maze by inputting the array. So the first things I need to add is to add a entrance and the exit of the maze in the maze generation function, create maze. So the entrance would be 0, 1, and the exit would be 0, 2, 0, 1. So this is the entrance and this is the exit. So next, I'm going to add a function to find the path of the maze. So right now it just return a single point 0, 0. And I need to define the starting point. And the endpoint of the maze. Then I need to create a data structure. To do the breadth-first search. For finding the path. So the starting point will be 0, 0, and the end point will be maze dot shape -2 and maze dot shape -1. So the data structure I'm going to create is an array of visited node or path. I use a numpy function, zeros this, to create an array of true and false. So maze and data type is equal to Boolean. And I set the first visitor point to be true. I also need a queue to save the visited node. And the path. So the first visitor node will be start, and the first point of the path is always to be start. So I could go through the queue and check for the first element which enter the queue. So in here I could use note path is equal to queue dot pop left, and x is equal to note 0 and y is equal to note 1. And also I need to find the direction of all the possible paths. So in this case, 0, 1, 1, 0 means going left. Negative 1, 0 means going right. 0, 1 means going, oh, the first one means going right. The second one means going left. And then this one means going up. And the last one, 0, negative 1 means going down. I need to go through all the directions. So the next node or the next path will be dx plus x plus dx and y plus dy. And I need to check if the next path is a valid path by checking the dimension. And also I need to make sure that it's not visited. And it's a valid maze path. So if that's the case, we can mark it as visited. And we can add that in the existing path. I mean in the existing queue. There's one more thing which is very important is to check if we have visited the endpoint. We could do this by doing the checking here. Then endpoint is visited. Then we can return the path plus the endpoint. Let's check the result and see if it compiles. Okay, function name, type errors, take exactly 2 arguments. Append. Okay, I should add one more bracket here. Okay, here there's a typo. Okay, here's the path. I think there's something wrong with the beginning of the path. So instead of entering 0, 0, I should add 0, 1. Okay, here is the path. Let me check it with a higher dimension maze. 50. Okay, and here's the path. It's not at the moment. The maze only has one path from the beginning to the end, so there is no shortest path, or there's only one path, and the path is the shortest path. And I can check it again with a higher dimension.